we are talking about matrix notation, matrix multiplication. So, what is matrix notation? Like, it's why it is different. It looks complex in the sense I have a kind of a brace, and inside that we put items in row and column, and I can have two different matrices, and then we multiply. Multiplication happens in a kind of complex way, where first one's a row get first row get multiplied with the first column, and then we add. Then it becomes one entity. Then we keep on to what is this? Means what is matrix? Why? Means I know matrix multiplication. Means if two matrices are there, I know transpose matrix. I know inverse matrix. I know identity matrix. I know. Means I have seen it mathematics that matrix has importance. In algorithm in computer science, people go for high speed matrix multiplication, sparse matrix multiplication. What is matrix? Where it comes from? So, so that we'll see. So, example can be I have electric. I have signals. I have four signal source. So, four source through which signal is being received, and it has values. And now, four signal they are going to three output. How they would go? Means all four signals they have some attenuation factor, and four signals each they have separate attenuation factor, and they become output one. Again, four have different attenuation factor, and they become output two. Again, four have different attenuation factor, and they become output three. Like I have four input signal and three output signal. How four output signal would be converted to three input signal? So, like I have a cross connections, and so many formalities are there. Once it becomes the output. So, this definition of computation, where input and output are dependent upon a mesh kind of a structure, complex kind of. So that we'll see that how we can declare complex kind of structures in matrix, and then why matrix multiplication makes life easy. Then we go for a straightforward multiplication. Like if I go for a straightforward addition, I have 1005 in number. So I have number 7, and that I have to add 1009 times. So addition becomes difficult, and we go for multiplication. Multiplication becomes difficult in some scenario, and we go for integration. Like that, in some scenario, a simple multiplication becomes difficult, and then we branch it to matrix multiplication. So what it is, that we'll see.
Okay, so we'll continue on the discussion on matrix multiplication. Okay, so idea is why we need matrix notation. Means there is nothing called matrix. It's a simple number multiplication. Multiplication starts from addition. So why matrix comes into the picture when we have the multiplication of two numbers. After all, any computation happens between two numbers, then why we need matrix? Okay, so in introduction we'll see the linear multiplication, cross multiplication. Then finally it will come to matrix. We'll see what is matrix notation and then multiplication. So the idea is, that is kind of honing, is cross multiplication. What about this? I have a signal, okay, like kind of so there is an electronic circuit. Okay, and so there is an electronic circuit and it receives a signal. From somewhere. This signal strength that is coming is X, okay. So signal strength that is coming is X, and signal that is reaching here to the circuit. So X signal is coming and it is reaching here. What about this? I have in the signal, so there is a component here inside the circuit, and it modifies the signal, it attenuates the signal. So one signal has a strength X and there is a modification in the signal, that is W. So X signal comes in, get modified by W, then it reaches the circuit. A signal X, signal of strength X, it gets modified by W and then it becomes output signal as Y. Okay. Now this circuit modified the signal by W and does manipulation, and then it output the signal, new signal. The new signal is, the new output is Y. So X strength signal is coming, entering into circuit, modified by W, and Y is coming out. So the Y is W into X. Okay, so X strength of signal that is flowing inside a circuit, it is modified by W factor and then it is becoming output as Y. So output is X multiplied by W. So this is linear multiplication. What about this? There are two signals, X1 and X2. X2 gets multiplied by W2, X1 gets multiplied by W1, and it becomes the net signal. What about this? W1 into X1 plus W2 into X2 becomes Y. Now two signals get modified by two different weights, W2, one is W1, and finally they summed up to become the net signal. So there is one more now. Here we talked about one. Now there is one more. like this, and this signal get added up, and it generates Y. Okay, there is another signal now. Okay, now there are two signals, so we can call it as X1 and X2, but it generates only one output signal, that is Y. So now weights are different. The way it is, here it is W1 and here it is W2. Okay, so it is little complex. First is only one signal and only one attenuation factor and output. Now two signals, two attenuation factor, and then the output. So no, it's not only multiplication. One multiplication, two multiplication, and then addition. Then the output is coming. What about this? There are two outputs, Y1 and Y2. X1 has weight W11, W12 to generate Y1. Same Y1 equal to okay, so Y1 equal to X1 okay. Now Y1 equal to W11 X1 and W12 X2 and Y2 equal to W21. I mean now it is kind of a mess. We started with simple. One signal is coming, getting modified by factor W and output is coming. Now two signals are coming, getting modified by two different factors and sum up to a output. Now two signals are coming but there are two outputs. Okay, they are getting modified by four factors to generate Y1 two factors and to generate Y2 another two factors. So this is a mess. Now Y1 equal to same the way we had calculation. So Y1 and Y2 are two dependent parameters and X1 and X2 are two independent parameters, whereas W1, W2 these are kind of slopes, these are kind of multiplication factor. So we started with simple, then complex, then more complex. So this is the problem. What about this? Now I have four inputs and three outputs. All four inputs are connected with four different weights in three outputs. Can someone compute this? How I can provide a multiplication? So now Y1 equal to W11 X1, W12 X2, W13 X3, W14 X4. Y2 equal to W21X1 means it is something that it is quite messy. So we started with simple, became little complex, more complex, highly complex. Now four signals are coming. All four are connected to four different weights to generate three outputs. What about this? Four, there are two set of signals. One set of input signal 4, another set of input signal 4, and there are two set of outputs. One set of three outputs and one set of three outputs. 4, 4, 4. So this set of input get multiplied by these factors to generate y1, y2, y3. Okay. This set of signals again modified by same factors to generate y4, y5 and y6. Okay, now I have to write here. So I have written y1, y2 and y3, which is exactly same what we had earlier. Now I have to write y4, y5 and y6 the way it is written. I mean, it is out of handle. This much, but this is the real case. I mean, a set of signals, or if I have four wires, then one time this much signal is coming, next time this much signal is coming. And attenuation is same because this is a circuit, but first time output set will be different, next time output set would be different. It is similar like first time x1, x2 signal came, and next time same wire, there is no separate wire. Next time different set of signal came. Different set of signal came. First set of signal, different set of signal in the same wire. First set generated y1 and next set generated y2. Okay, this itself is complex. This itself is complex. What about this? Okay, so can we go for kind of simple solution, simple notation? Okay. Okay, so to recapitulate, we started with simple multiplication. It reached this stage, it reached this stage, it reached this stage, and it reached this stage. Can we address this through some kind of notation that will make our life easy? And now we came up with a kind of a matrix notation. So this is matrix notation. Okay. So this is matrix notation. If I have an input x1, x2, x3, this will be represented as row. So two set of input, two rows and weights. So for y1, these are the weights. Okay, so weights are common for all the outputs. So this is the weight for y1 and y4. This is for y2 and y5, and this is for y3 and y6. Output generated is in a row y1, y2, y3. So this is far simpler than if someone write this much mesh. I can just go like this. Okay. Now in previous we had like this. That can be represented like this. So we had x1, x2, x3, x4, y1, y2, y3. Now we have x1, x2, x3, x4, weight and y1, y2, y3. So this representation is called matrix representation. When we have mesh kind of a structure, where we have input and input get modified by weights and then it represent output, and it is a mesh kind of situation, then we can just write x1, x2, x3, x4 in a matrix in a one row, and then we can define the matrix for the whatever the we are material, and then the output. This is very simple matrix. So we can just, so I can bring in, okay, I don't need this. So all this complexity is gone. Not required. And simply this notation would come. So that is matrix. Okay. So I had x1, x2, x3, x4. So complex a structure. 3 times different weights and then 3 outputs. Okay. Can be represented in simple like this. Okay. Now for this kind of a structure, where input is 2 different set, output is 2 different set, and we can go for simple this kind of matrix. Okay. So what we just need to do is here one row and here one more row. That's it. This is matrix notation. Okay, so it's crystal clear. The matrix is nothing but whenever we go for a mesh kind of a structure, this kind of a structure, Okay, then we have to think about having a notation that is pretty simple. So we come up with a matrix. Okay, so for this is the matrix. For this much drawing, left to right, and this much showing, I can just show like this: x1, x2 multiplied by weight and generating y1 and y2. Okay, so just think about writing this diagram and just this much to this much to this much. Okay, so this is matrix notation. Rather than going for this much kind of Herculean task, just this much. So matrix is nothing but a cross way of a structure notation. So if this is then this is the notation. Okay, pretty simple in this form. So this is the notation. Okay. Okay, so we'll come back with our initial business. So we talked about matrix notation rather. What is the property of matrix? When we say x1 weight multiplied generating output, signal is flowing from left direction to right direction. Like in our structure, this is the x1, x2, x3, x4. This is the weight and this is the output. So signal is flowing from left to right, not from the right to left. So this is not the flow. Okay. So x1 multiplied by w is not equivalent to w multiplied by x1 because we are trying to make it in reverse direction. Signal flowing in one direction, it is not reverse direction. So matrix multiplication cannot be reversed. Okay, like in simple multiplication, x into w equal to w into x. But in matrix multiplication, unfortunately, reverse is not true because then we are flowing the signal from right to left. This is not we are intended in the electronic circuit. Okay, so we'll go with the lab session. So we had earlier this session, and now in Python we'll write code to have matrix multiplication. Okay, so I have a matrix like this and this. This is the weight, this is the input signal, and we'll generate the output. This is the lab session. Okay, how matrix multiplication happens? That is a question. Okay. So if I see this matrix is of dimension 2 row by 4 column. There are 2 rows and 4 columns, and another is 4 row multiplied by 3 columns. Okay, this will lead to 2 into 3 matrix. This is what the output is. 2 rows, 3 columns. This is what we are trying to achieve. Okay, Can we come up with like a formula now? Okay. So m into n into y into anything n into o equal to m into o. So these two n is gone. In matrix multiplication, in the output, this has no importance. The first matrix row comes into the picture and second matrix column comes into the picture. In between n goes, but it must be equal. If column first matrix column is n, in next matrix row must be n. Okay, so it will become m into o. This is not true. Because these two are different. O and m, it should be same. First one's number of column and next one number of row must be same. Here both are same, n and n. Now matrix multiplication can happen. It will lead to another matrix with m row and o column. Okay. How matrix multiplication happens? Okay. So first row would get multiplied to the first column. Okay. So 0.8 would get multiplied by 2. 2 get multiplied by 0.4. 0.2 would get multiplied by 0.6 and 4 would get multiplied by 1.2. Okay. This would lead to first element here. Now this row got multiplied by first column, it would get multiplied by second column and it will lead to second element here in first row. Similarly, it would get multiplied by third column and it will lead to third element in the row. So first row is complete. Now second row would come. Second row would get multiplied by first column, second column, then third column. And it would lead to all three elements when it get multiplied by first column, first element, second element, and third element when it is get multiplied by third column. So this is the matrix multiplication. Now we'll proceed with the computation. Okay, so we'll have a Python session now. Now we'll write the code. So we'll create a directory temp matrix multiplication. Okay, we'll have a file called mm.py. Now we can type in the matrix whatever we have. So this is the matrix. Zero 0.8 to 0.24 and 2 0.1 3 and 2. So this is the matrix. Okay, now I have another matrix called W equal to. So we'll copy this matrix. W equal to 2, 3, 0.8, 0.4, 1.2, 2.1, 0.6, 1.4, 0.6, 1.2, 1.5, 3.2. So this is the matrix finally. So 2, 3.8, 0.4, 1.2, 2.1, 0.06, 1.4, 0.6, 1.2, 1.5, 3.2, 2, 0.24. Okay, so our matrix is complete. Okay, so we'll proceed on writing the code. Okay, so this is the program. So we have right now two matrices. Now we'll have output matrix y equal to 0 into len of w0 for count in x. That's it. So now we are defining x, w and y the way it is here. Okay, so this is x, this is w, and this is the y that which need to be generated. So x, w, and y. So the way we have brought the formula, so x row and w column will become row and column of the y. Same thing we have written. Count in x, so all the row in x, we have 0 initialized, length of the w0. So w0 is nothing but number of the column. So this array, this array would become number of rows in x, and each row will have number of column in w. Now we'll write for I in len x, for j in range len w 0 the way it is, and we'll have the output I j equal to mul. So we will have a function called multiplication xi xj for x in w. Okay, so this is the complete program for matrix multiplication. We iterate in x and then we iterate. So these are two are numbers. So yij will be xi. Okay, that is okay. So xi is the number. So rather, so xi that is number. So xi would be the. Now we'll go here. Okay, so we are multiplying first row with first column, first row with the second column, first row with the third column. So in the program, what we are doing is xi, if I is 0, this is the first row element, and we iterate in w, and if j is 0 means first column, all first column in the w would come, and it become the one array, and it become the second array. These two array will multiply and add, so we'll have a function now. def mul, it will take two array and it would return some x count into y count or count in range length. So length of x and y are same, anything we can put. Okay. Now it is complete. So I have a multiplication function. It takes two array and then it iterates through one array, getting the count, and x count into y count, multiply, and at the end sum everything, return that mul. So this is the first row. If I is 0, this is the first row, and in W we iterate all the row, and for every row we take the jth column. So first it is 0th column, that is first column, second column, third column, and then we multiplied by row, and then we come to yij. So we can print the y at the end. Print y equal to. So we can say print x equal to, then we can print w equal to, then we can print y equal to. So this is the code. Okay. So we'll try the way we have come up with the fundamentals. So I can say python 3 mm.py. Oh, it is coming. Now I have the output. It is two array, one row and second row. In each row there are three elements, exactly like this. Now we have two rows and each row has three elements. First row is 7.32, 11.08 and 17.76. So we can copy paste there. Okay, so this is the output we are trying to get. So we'll paste it here in the output. Okay, up to this much only we'll have it. Okay, so this is the first row. And we'll paste second row. Okay, so first row and second row. So this is the output. We can try actually. So 0.8 into 2, that comes to 1.6. 2 into 0.4, that is comes to 0.8. 1.6, 0.8, that comes to 2.4. Then 0.2 and 0.6, that comes to 1.2. 0.12. Okay, so we have now 0.8 into 2 and 2 into 0.4 and 0.2 into 0.6 and 4 into 1.2, that would come as 1.6 plus 0.8 plus 0.12 plus 4.8, that would come to 8, 9, 17 and 6, that is 3. So we'll have 0.3, 2, and then we have 4, 1, 5 and 2 from that side, that is 7. So 7.32, this is exactly what we have got, 7.32. So this is matrix multiplication. It is far easy than going with these complex notation. So, what we had linear multiplication followed by little complex, more complex, more complex, more complex. So, in reality, we saw that this much is not possible to show up. Then we came up with mat kind of new notation. So, in new notation, we have matrix kind of fundamental like this, and then we go for matrix multiplication. Okay, so matrix, we saw that matrix is not reversible, like multiplication, we cannot reverse it. Then in the lab session we had a matrix, so matrix multiplication we did through cross multiplication addition, we came up with the result. So we wrote this code to came up with the